get cooking here. So we have this New Keynesian model that we discussed so far. There's one problem though. If you were to start MATLAB and were to type in these equations into Diner will give you an error message. You literally take those two equations into Diner, and you've learned how to do this, and you say, look, solve the model and give me impulse responses or simulate the model. Diner will give you an error message. Can somebody think about what that error message could be? So even though you didn't make any coding mistake, there's a conceptual problem. What's the problem in this that you see here? What's the conceptual problem?
Does anything to do with you have to train the thing first?
The trend first? No, that's not it. But good try, but no, that's not it. It's easier. It's maybe too simple. You guys look like bookkeeping. Was bookkeeping your favorite subject in your bachelor's? Let's do a little bit of bookkeeping. Let's keep track of what we have on the left-hand side and the right-hand side. Okay, look, that's one way to think about it. Let's count the number of endogenous variables. Okay, so what are the endogenous variables in this model, right? So what are the endogenous variables? Endogenous variables. So what are the variables that move endogenously in response to shocks? Can somebody help me? So what is an endogenous variable in this model? What letter do we have here? Anybody want to give it a try? What is an endogenous variable? Inflation, for instance, right? So pi t head is one endogenous variable. When there's a shock, pi t moves endogenously in this model. What other endogenous variables do we have? The nominal interest rate, right? RT is also going to move around in response to shocks. Okay, perfect. Anybody else wants to give a try? What else do we have here in terms of an endogenous variable? There's one more.
GDP.
XT, the output gap, right? XT is another endogenous variable, XT. And that's it. So this model has 3 endogenous variables. Okay? So there's going to be 3 endogenous variables in this model. Pi, R, and X. What is the exogenous variable?
The technology shock.
Exactly.
Money supply shock.
Exactly. Well, be careful. There's not dead there, right? So there's the technology shock. That's the exogenous variable. So this is exogenous. It's also an AR1 process, right? Okay. So now let's count how many equations do we have. How many equations do you see here? It's trivial, I know. 2, right? So we have a model that has 2 equations, but it has 3 unknowns, right? So go back to your basic, math or whatever. When you have a system of linear equations of 2 equations and 3 unknowns, it's typically a problem, right? You cannot really solve that. There's an equation missing. That's all I'm trying to do here. So the bookkeeping analogy was count the number of endogenous variables, count the number of equations, and make sure in your research that the number of equations equals the number of endogenous variables. If you are short an equation or you have too many equations, problem. So all I'm trying to say here is that we are missing one equation. We have one equation to compute. If we have 2 equations, we missed one additional equation. And that equation is something with thinking about R that determines somehow the normal interest rate. Now you can think about finding optimal monetary policy. We have done that with Alexander Meyer-Gode, trying to find what is the optimal way for the central bank to react. Another way in this literature is to think about monetary policy going back into, be more rule-based. So in other words, to close the model, to get to that third final equation, what we're going to do is we're going to do it an interest rate rule. So we're going to think about that the Federal Reserve, that the ECB, the Bank of Vietnam, they follow some feedback rule, some interest rate setting rule. You can also do money supply rules, money growth rules, but the literature, has basically followed a very famous economist, John Taylor. And John Taylor, proposed this Taylor rule, and ever since that became the third equation in this New model. So that's going to be our third equation. Now, to introduce this, so John Taylor wrote this paper, 30 plus years ago, and he detected something so fundamental and so important that it, became that it was, his name was tagged on to it. That's why it's called the Taylor rule, because it's his last name, John Taylor. So if you write a great master thesis or a great research paper and it becomes path-breaking, be prepared. It may carry that thing that you found, may carry your last name or your first name, depending on your name. Okay. So he basically says that the nominal interest rate that the central bank sets in an economy is a function of the rate of inflation, where phi pi is a parameter. So phi pi is a parameter that measures when the central bank observes inflation to, say, go up by 1%, then the central bank is going to increase the nominal interest rate by the 1% times, say, phi pi. If phi pi is 2, then a 1% inflation rate means the interest rate goes up by 2%. So that's nothing else than just thinking that the central bank is going to step on the brake. When inflation gets high, the central bank raises the nominal interest rate. It's trying to do that to slow down economic activity, to slow down inflation. And second, the central bank responds to the so-called output gap. If the economy is hot, if the economy is, in a sense, hot, that you have a positive output gap, so actual output exceeds potential output. So the economy is in overtime mode. Then the central bank increases the interest rate. Third, there is a deviation from the rule that the literature interprets as a so-called monetary policy shock. So this is a monetary policy shock. It's called a monetary policy shock. So monetary policy shock. So you can interpret this as a deviation from the rule. So the central bank follows this rule, but then occasionally it may deviate. And what are the things that you can interpret what this thing is? Well, it's a deviation from the rule in the sense of, the central bank may look at other things than inflation and the output gap when deciding about policy. It could be expectations about the future inflation rate that matter for the interest rate setting. The central bank, expects inflation to be high. This will move. But they may increase the interest rate if they say, look, we expect inflation to come in high in the future. They may look at, bank stress measures, financial market stress. Nothing of that is embedded here, and so you can think about their own nets in there. You can also think about this like when there is a committee in the central bank. There's an executive board, and you have different views about the economy. Some board members may say, oh, we should raise the interest rate. Other board members say, yeah, we should raise the interest rate by much less. So then, it's maybe they take a compromise. Okay. So even though inflation would dictate the interest rate to go up by 2%, because some committee members don't agree with that, in the end it's only going up by 1%. So you have a shock basically, an exogenous shock that captures disagreement, and so forth. Okay. Good. So that is the so-called Taylor rule. Now, you could say, wait a second, I just come up with something else. Why is this thing so famous? So Taylor actually compared this rule to the actual data. And so here is this plot from his paper. This is from his paper. And this goes with the data that he had at the time, from the mid-80s to 1993. And the policy rate is the solid line. So this is the actual policy rate in the US. And his rule-based rate, right? So the Taylor rule rate is this dashed line. And at the time, this was unthinkable that a simple rule like this Taylor rule would be able to depict these big, so to say, that would be able to get close to the federal funds rate. That was unthinkable. I mean, so the rule, right, it's not a perfect match, but look, when the actual interest rate goes up, the rule says it goes up. The rule gets the turning point right. When the interest rate starts to fall, the rule-based rate falls, and it tracks the actual rate pretty well. There are differences. This is not like on every point in time. That's how you have to think about the differences are deviation from the rule through the lens of it. So this is basically the policy shock. Here, the rule is more loose than the actual policy. Here, the rule is more tight than the actual policy. But it tracks this in like big picture movements, if you like. At the time, this was path breaking. You know why? Because central banking in the 1980s and 1990s was very different than today. What we have today is that central banks give press conferences. They inform the public. Right? Christine Lagarde, Jerome Powell, they give press conferences and tell the public, we have decided to increase the interest rate. And going forward, it's going to be likely that the interest rate is going to remain high, or we have decided to cut the interest rate, and going forward, we're going to think of further cuts going forward. So there's a lot of communication these days between the central bank and the public. In the 1980s, 1990s, there was no such thing as press conferences. Alan Greenspan gave sometimes interviews, and those interviews were incomprehensible. And I mean this in a very respectful way. Deliberately, he was not releasing information. He was literally talking about the economy. There was no decision-making process communicated to the public when central bank officials were speaking. The only way for the markets to understand that the central bank cut the rate or increased the rate was to observe ticker data on interest rates, whether the central bank intervened in the markets. And that's when, so to say, they had to figure out, oh yeah, something was happening. It was incredibly complicated, very intransparent. And then comes John Taylor and says, well, I can predict what the interest rate is going to do very quickly, very transparently, and very simply. That was really, at the time, unheard of, to come up with this very simple rule to describe what the central banks actually were doing. Now, ever since that happened, of course, we have much more data, and people have extended this in terms of the time, of course, until today. Okay, so there's a million studies that actually go all the way to 2025. I have students who did that, master students, bachelor students, who looked at how does this rule perform in various episodes. There's lots of research papers, and they all show that over long times of over long samples, this rule is pretty good at getting the big movements. There's always going to be some gaps for sure, but the big movements up and down and the turning points and for many periods, this is pretty good. That's the reason why this rule has become a standard element of the New Keynesian model. So, if you ever wonder, so why is this New Keynesian model having now these three equations and the third equation always being the Taylor rule? It's because it's simple, it's transparent, and it tracks the data very well. Okay? That's the reason why the three equation New Keynesian model looks like this. Any questions on this? Now, I want to make sure that everybody's on board on what is now the transmission mechanism in this model. Okay? How does monetary policy affect the economy? Right? Remember, we are coming from this empirical evidence that we received, that in the data, an interest rate cut leads to an expansion in economic activity. But that's just the data. We don't know what really drives this. The model has the advantage of telling us, when the central bank cuts the rate, why does economic activity go up? And the thing that is the important, so to say, element in this model is the so-called real interest rate channel. It's really the real interest rate. emphasize this enough. Nominal interest rates don't matter. It's the difference of the nominal interest rate minus expected inflation, the real rate, that matters. So when a central bank decides about what interest rate level to set, the central bank has in mind, oh, when you set the interest rate in nominal terms to 4%, you subtract expected inflation. Oh, the economy is going to have X% in the real rate, and we think the economy should have that real rate. So central bankers always think about the real rate, because that's what's going to affect allocations. The nominal rate doesn't matter. If I tell you, Ivy, you get 100% nominal interest rate if you invest in my firm. You should say, well, 100% nominal interest rate sounds great, right? You should say, oh, 100%, like over what, a year? You should say, that's great. But frankly, this 100% in nominal terms means nothing. If you give me 100 Vietnamese dong, and I promise to pay back 200 Vietnamese dong next year, that smells like a good deal. That's like, oh, 100% rate of return, I double my money. Well, that sounds fantastic. But frankly speaking, this is not how economists think, right? Because 200 Vietnamese dong in 1 year from now, well, it matters nothing if the price level has quadrupled compared to today. So what's right, the whole idea is you should always convert things into the real rate of return. What are the amounts of goods you can buy in 1 year with the 200 Vietnamese dong? And if the prices stay the same, it's a fantastic deal. Your real rate of return is 100%, right? If the rate of inflation is 0, prices don't change from today to tomorrow or next year, 100% nominal return implies 100% real return. You can buy twice as many goods with the investment you did. If the prices double too, if the rate of inflation is 100% from today to tomorrow, your rate of return is 0. Yeah, you got twice the nominal money, but price is doubling. You can afford the same amount of goods, but you cannot afford more. So that investment doesn't look so good all of a sudden. It's exactly what's going on in this model. It's the real interest rate channel that matters. So let's go through this, and then everything that's in this bullet, we're going to do now together. Okay. So suppose the central bank cuts the normal interest rate unexpectedly. So suppose there is a press conference, and they're coming out and saying, we have decided to cut the normal interest rate. So that's the impulse. Right? That's how this economy is perturbed. And it's unexpected, so it is not driven by fundamentals. So it's not driven by output or inflation being different than what people saw. No, it's a press conference where the central bank decides we think it's appropriate to cut the rate. Okay. So how does that now affect economic activity? Well, you have to first think, where does the interest rate show up? Well, it's showing up in the IS curve. So when the nominal rate is cut there, ceteris paribus, so keeping inflation, everything unchanged, right? And you can see when the interest rate falls, this falls by the negative sign, it should move up the output gap, right? That's the basic idea. But now be careful. When you remove the ceteris paribus idea, you say, okay, when the central bank cuts the rate, it's going to be, easier to lend money, and that could, so to say, drive up inflation. That's exactly what's possible here. If expected inflation moves in response to the rate, and it moves up or it moves down, then it's going to, there's a possibility that that the real rate is unaffected. So long story short, if the inflation expectations are sticky, so if this thing moves little, move that up here. So if this moves little, if moves little, the real rate falls too. And so where this whole idea is that this is the real rate of return. Okay. That's important. Okay. So when inflation expectations are moving little, in other words, when you have price stickiness, when prices are sticky, when firms don't adjust their prices because of the quadratic adjustment cost rule, right? When that happens, firms are not wishing to move their prices around like crazy. When expected inflation doesn't move at all. then the real rate actually can drop. And that's what the central bank here is looking for. He's saying, wait a second, we think we should cut the normal rate. Either. Oh, it's this thing again. Okay. 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 So, right, when we cut the nominal rate, right, when we cut the nominal rate and inflation expectations don't move much, we're going to cut the real rate. Okay? So when you cut the real rate, then the lower real interest rate by the minus sign means you're going to increase output, or you're going to increase demand. The idea is the following: if you cut the real rate, now it's less attractive to save. Right? Every rate of return, you're saving your standard thing, and then all of a sudden the real rate is smaller. Now it's less attractive to save. Every euro or every Vietnamese dong that you're saving, yields a lower rate of return, becomes less attractive to save. And so what do you do if you're gonna run down? You say you're gonna decrease savings. What's gonna happen? You're gonna spend more. It becomes more attractive to spend than to save. When you spend more, output goes up. The output gap goes up. Now, this is a general equilibrium model with the output gap going up, with xt increasing, right? Via the Phillips curve, you can now see, oh, inflation's going to go up. So the idea is that if output goes up, if demand goes up, so people demand more tomatoes, right? Somebody has to produce that. Somebody has to produce those extra tomatoes. Who's going to produce it? The workers, right? Fine. So workers have to produce more. When the workers produce more, they're going to ask for higher wages, at least some. And higher wages are going to increase marginal costs of firms, right, too? And so higher costs of firms increase inflation. That's the whole idea. So the demand channel from X to pi is exactly embedded via that Phillips curve. Hey there, we need to do the microphone. Do we have another microphone? Oh, I see, okay. Does this work? Okay, does this work? Thank you. Perfect, thank you very much, appreciate it, thank you. All right, so in other words, it's the real interest rate channel that, that drives the transmission of monetary policy in this model. And the models we're going to discuss in this course, the macro climate model, the monetary fiscal interactions model, it's exactly the same way. And notice that these results, these directional responses, is exactly what we see in the data. This is consistent with the data. It's consistent with the VER evidence that we discussed. Right? We remember those gray areas, those impulse responses from the data? Right? We saw that in those impulse responses, when the real rate drops, or when the central bank drops the nominal rate, the real rate drops, we saw that produces an expansion in output, that produces a run-up in inflation. Okay? That's exactly the way to think about how this model squares that empirical evidence. There we go. Okay. All right, good. So that's the basic bottom line of how to think about how the central bank actually operates in this economy. Are there any questions on this? Excellent. Well, then let's move forward. The final part, that's where maybe this gets a little, The final part of the slide deck, we have, I think, 3 or 4 slides left. The final part of the slide deck is now thinking about, okay, let's put on numbers. Rather than going through this qualitatively, if R changes, then pi is going to increase and X is going to increase. Let's do this quantitatively. Okay, let's see how this model behaves quantitatively in terms of numbers. And for that, let's assume that the 2 shocks are following AR1 processes. Okay, so there's 2 shocks. There's the technology shock. We already worked with this as an AR1 process. And let's also assume that the monetary policy shock is also correlated. Okay? So when the central bank cuts the rate, it's going to stay down low for longer, right? So in line with this, right, that these differences you can interpret as these multi-shocks. You see that they are autocorrelated. When the central bank's rate is above the actual rate, then this is persistently the case, at least for some particles. Okay, so that's that. We have AL1 processes, and then we these are parameters. When you want to work quantitatively, you have to work with parameters, and these parameters are taken from the literature. So first of all, time is quarterly, so time t is quarterly. So that means that every time unit is 1/4 of time, quarter of a year. And then most of these parameters we have discussed with Alexander Meyer-Gode and with Michalis Haliastas, and maybe also with Michael Binder. The Taylor rule parameters, some of the utility parameters. The demand elasticity is set to 6, and that implies, as we discussed, that implies that the gross markup mu is equal to 1.2. So that means the net markup is 20%, as we discussed. The only thing is maybe this omega equal to 60. Where does this come from? So setting this omega equal to 60, well, what you can do is you can think about where does omega show up in this model. Omega shows up in this model in this parameter here. Okay. So let me write down that parameter for you. No, wait a second, let me go back. Sorry. I don't want to rush it. There we go. I'm looking for something else. I'm looking for this. So if you go to the data, right? If you go to the data, you can measure in the data what should that coefficient be. You're running an OLS regression. You take data for firm's marginal cost, you take data for inflation, and then you want to run a regression, and you're going to get a regression coefficient that's this one. So in the data, this thing is approximately 0.1, roughly tough. I mean, really roughly tough. Depending also on the sample, and actually there's lots of hand waving here, but roughly tougher. So how can we get that? Well, if theta is equal to 6, right? So you have theta minus 1 over omega is supposed to be roughly 0.1. If theta is equal to 6, then omega equal to 50 or 60, roughly toughly, is going to get you into the range of this being 0.1. So we could set omega to 50 or omega to 60. I'm setting this to 60 because this is like trying to nail this some further digits. Okay. But long story short, the reason why omega is set to 60 is to get to the slope of the Phillips curve. That's, so to say, the discipline that is applied here in terms of this model. And then the autocorrelation coefficients and the standard deviations of shocks are just set to standard values. So this is the slope of NKPC coefficient. All right. And then once you have that, you can solve the model. You can solve the model. Meaning, with these parameters, you can now numerically evaluate, so to say, this model. Now let me ask you, when you did this with Alexander Meyer-Gode, did you cover how to solve this model with pencil and paper? Have you heard about the method of undetermined coefficients?
Yeah.
Have you heard about the guess and verify?
Yes. Yeah.
That's exactly what this is. Okay, that's exactly it. So the way to solve this model is to use the guess and verify approach. So the idea is that you're gonna first of all reduce the complexity of the system from 3 equations and 3 unknowns to 1 equation and 1 unknown, and then you do guess and verify. And then the guess is you're going to guess that the solution, say for inflation, is a function of the state variables of the economy. Does that ring a bell? One, you say yeah. Okay, so what are the state variables? Well, there's no endogenous state variable in this model. It's just that there's 2 exogenous. So you're going to guess that the solution for inflation is a function of the exogenous state variable technology and the exogenous state variable monetary policy shock. And then you have these two undetermined coefficients, eta z and eta upsilon, that you are solving the model for. Now I wrote a full appendix for you if you want to refresh your memory on this. Okay. So the appendix does this step by step. It sort of say takes the model. First of all, the appendix does the following. It takes this model, it plugs this R in there, and it takes this Phillips curve, solves it for x, and plugs this x in here and in there. So that gets rid of two equations. You're left with one equation in inflation, and then you do the guess and verify on the inflation equation. So very straightforward in terms of what you have done. Okay? And then you can solve for the solution. How does this economy respond to monetary policy shocks and inflations? We're going to be working with this. I don't know whether we're going to be able to do this tomorrow, but on Thursday for sure. Okay, we will be working with MATLAB and Dynair, and I posted this on Moodle actually. It's not Colab, it's Moodle. Sorry about that. Right. So there is this file nk.mod on Moodle. Let me go to Moodle, right? And where I colored up this model for you. It's a couple of lines, but we will be working with this when we have our hands-on MATLAB and Dynair sessions. And so Dynair does all this work for us, okay? In terms of running, solving this model. In the background, this is what Dynair does. All right. So what we got out of this year, and we discussed this already yesterday. This is essentially the impulse responses of this model to a sudden cut in the policy rate. And it's useful to discuss this in this counterclockwise direction. Okay, so let me start and maybe put in as much intuition as possible here. The whole idea is that there's two lines. There is a red line and there is a blue line. For now, you only look at the red lines. And the red lines is the case when prices are sticky, when omega is set equal to 60. So the central bank cuts the policy rate unexpectedly, so that's a negative monetary policy shock. So -1 here means it's a 1% fall in this upsilon exogenous object. As a response, the red line says the normal interest rate falls and then comes back to steady state. So in other words, the number 0 here means there is steady state. Everything is expressed in percent deviation from steady state. Central bank cuts the interest rate, and then the interest rate normalizes over time back to steady state. As a result, what we see is that the real interest rate also falls in this model, okay, with sticky prices. Again, what is the real interest rate? RRT hat. It's nothing else than just the normal interest rate minus expected inflation. Okay? So that is the real interest rate. And we see in the red line case, the cut in the nominal rate translates to the cut in the real rate. Actually, right, because the nominal rate falls, if expected inflation goes up, it actually aggravates the fall in the real rate. Okay? So the real rate falls by more than the nominal rate actually. So the nominal rate falls by 35 basis points, while the real rate falls by 0.5%, a little more than that. Now with the real rate now falling in the sticky price case, now it's the time output is going to be going up. So with the real rate down, output increases. It's exactly the idea that now saving is less attractive. When the real rate of returns are smaller, it's less attractive to invest. You're going to consume more, and when there's going to be more demand, that demand is going to be satisfied. There's going to be also more supply, and so output or income is going to go up. And now with output going up, we're going to see that the output gap also goes up. And if you look closely, a dear friend of mine always says, in macroeconomics, numbers are everything. Quantities matter. When you look very closely, what you're going to see is that the increase in output, YT, is the same as the increase in the output gap. So output and the output gap go in the same direction and go up by the same amount. How the heck is that possible?
Because on the flexible price is 0.
Perfect, okay? Let me write this out. So the definition of the output gap was it's output, right, in deviation from steady state minus yt hat f, right? That's the definition of the output gap. And flexible price output, right, we had worked out is 1 plus eta over sigma plus eta times zt hat. Right? Flexible price output is only affected by technology shocks. This is not the shock. Here we have a monetary policy shock. So when a monetary policy shock hits, flexible output is actually unaffected, so that is equal to 0. Okay, so this is equal to 0 here. There's no technology shock. So that means when flex price output doesn't move, okay, and that doesn't move, output and the output gap move 1 to 1 to each other. That's what this means. Okay. Last but not least, right, what you can see is that with higher output and a higher output gap, via the New Keynes and Phillips curve, you're going to get more inflation. That's the standard New Keynes and Phillips curve effect now. With more output gap, X is elevated, right, you're going to get more inflation. So that's the impulse response. That's how you can think about what's the transmission channel, illustrating that in the quantitative way. Any questions to that? Now you're allowed to look at the blue lines, at least for a split second.
How come after the monetary policy shock, under the flexible prices, the nominal interest rate increase? I just don't get it.
Exactly. Okay, let's go in steps here, folks, first, and let me talk about that one. So let's go back for a split second onto the red line, for just a split second. Notice that the shock was put down by -1, okay? And so the central bank intends to cut the nominal rate by 100 basis points, by 1%, but it only cuts it by 30 basis points, roughly. What's the reason for that? Well, let's write down the Taylor rule. So let's write down the Taylor rule, which is RT hat is equal to phi pi t hat plus phi x xt plus upsilon t hat, right? So that's the Taylor rule. This one is cut by 100 basis points. Okay? So this one goes down by 100 basis points. But as we see, because both the output gap and inflation go up, there are two objects in the Taylor rule that go in the opposite direction, right? So inflation goes up and the output gap goes up. Now it depends on the relative forces of those objects, what the actual interest rate is doing. So this goes down by 100 basis points, this goes up, and in the red case you see, the nominal interest rate only goes down by 35 basis points. This falls by 100, so in other words, 65 basis points is the effect by which this is pushed up. So this goes up by 65 basis points, this goes down by 100 basis points, and the net difference of those is the 35 basis points fall here. I come back to your question in a second, but that's important to keep in mind. Now with flexible prices, the central bank cuts this, wants to cut this, let's come back here, but the basic, understanding is that with flexible prices, the real rate is unaffected. In other words, the nominal rate and expected inflation move 1 to 1. And we have to understand, where does the nominal rate move to? Where does inflation move to? But let's first look at inflation. With flexible prices, we shouldn't be surprised that inflation moves up by more than with sticky prices. When prices are sticky, inflation does what it does. But when you make prices flexible, you would expect every firm to increase their prices by more than with sticky prices. So we know that the blue line is strictly above the red line. So with flexible prices, what's going to happen is that we have this trajectory of inflation being above. We also know that with flexible prices, when prices are perfectly flexible, we know that output doesn't move. Because, that's a little circular argument, that because the real rate doesn't move. So the real rate doesn't move because the difference between RT and pi t is such that they move in tandem 1 to 1. In other words, when inflation goes up by more, so inflation goes up by some amount, it must be now, for the real rate to be unaffected, it that the nominal interest rate must go up now. And that's the reason how to think about, why this blue line goes up. There's two ways of thinking about this. One is that with flexible prices, this term disappears, right? Because the output gap doesn't move. Output doesn't move. Flexible price output doesn't move. So the output gap doesn't move. Right? So that thing is zero. But because inflation now goes up by more, the two things, again, need to the net effect on the interest rate is how much the inflation rate rises versus how much the shock. And you end up in equilibrium maybe on net that the nominal interest rate actually can go up with flexible prices. And that's exactly what this is. And it goes hand in hand with the idea for the real rate to be unchanged. Right? And for inflation going up by more, you need to have an increase in the nominal rate. That's the intuition, so to say, for this. It's a little weird effect, but it's not the world we're living in, frankly speaking, and that's good. So long story short, with flexible prices, you see more inflation. The central bank can move the inflation rate, but it has no lever on economic activity. And notice that this is in sharp contrast to the evidence. If you're of the camp and saying, I think the world has flexible prices, well, unfortunately, I have to say, the empirical evidence speaks exactly against that type of idea. Empirical evidence says, when the central bank cuts the rate, you're going to get more economic activity. The sticky price model is consistent with that. So the flexible price model is inconsistent with that. So the flexible price model is not a good description of the actual. All right, more questions? Now, for time reasons, I know that we are, you may expect us to do macro climate today, but I think it's important to fix these understandings, importantly, to understand the macro climate and monetary fiscal interaction stuff. So we're running in my mental schedule, a little behind schedule, but don't get nervous. We will have enough time to talk about macro climate in the coming days. But I think it's important to really be 100% on top of, so to say, what is the intuition and what are the mechanics in the New Keynesian model, because all that will be important to understand the research frontier papers starting, when we're going to go into that. All right, here is the interpretation in terms of giving words to what I just said. This is exactly what I just said in words. We are not going to discuss this deeply, so these are the impulse responses to a technology shock. It's a positive technology shock. And the idea is that technology goes up, and again, there's two lines. For now, look at the red lines over here. So when technology goes up, Z improves. What you're going to see in this model is that inflation falls. Can somebody think about a mechanism? Why the heck does inflation fall when technology improves?
Because the potential output increases.
Potential output increases, right? So when potential output increases, there's something there. That's right. And that's what you see here. Where is this? Yeah, that's right. So it's actually right underneath here. Sorry. So this isn't actually plotted. So the red also has potential output going up by the blue. Okay. This is why. But I'm looking for an additional channel. So when technology goes up, why are firms cutting their prices? So they literally reduce the price of tomatoes in the supermarket or at the marketplace when technology has improved.
Does technology mean better productivity?
Exactly. Better technology means better productivity. So when ZT goes up, they're more productive. How is this showing? Well, it's showing in the production function, right? So we have CT is ZT times NT, and when productivity goes up, for the same amount of hours worked, you can produce more output. And that's good news. Okay? But in terms of marginal cost, right? Think about marginal cost. How did we define firms' real marginal cost? That was the nominal wage divided by the price level divided by productivity, right? So firms' marginal costs it's the nominal wage divided by the marginal per load labor in normal terms. So that means when technology goes up, it reduces the costs per unit of good produced. That's important. When technology goes up, you can produce cheaper than the output you produce. For the same amount of labor that you're employing, if you figure out the magic app to do better watering of your tomato plants, you're going to be harvesting more tomatoes. So better technology reduces the unit cost per unit of output. That's the definition of marginal cost. Once you get that, we understand when firms have lower marginal cost, what do? They pass this on to prices, at least in part. Right? Every firm has an incentive to do that. So suppose you are a firm, has a firm that says, I'm not going to pass my improvements in technology onto my prices. Suppose you're a firm like that, saying, oh, I just figured out the magic sauce, and I can produce better, and so you're not, cutting your price. But then An comes and says, and now you have the same discovery, so you're all using the same app to water your plants, but you are cutting your price. Then what's going to happen is that you're going to see more demand, you're going to see less demand, because your price is now too high still relative to the better technology price. So you're going to, cut your price as well. So in equilibrium, everyone in the economy is going to cut prices because of the pressures that nobody wants to lose market share. So when everybody cuts prices, then what's going to happen is that so marginal cost, the fall leads to the fall in inflation. That's the whole idea. That's what we see. The economy is benefiting from this. And then, so when inflation moves down, the central bank cuts the normal interest rate as a response. So we say this is accommodative monetary policy. And the central bank observes inflation to slow, right? The central bank wants to stabilize inflation around some 2% or some numerical goal. And when the central bank sees inflation falling, it's going to cut the rate of inflation. All right.
Sorry,
Yeah.
Can I ask?
Oh, sure.
In this kind of model, do we make any assumption on the parameter pi in the Taylor rules?
Yeah. So these are set to what John Taylor set these parameters to. Okay, so 1.5 and 0.5 on annual data. If you're on quarterly, model, then you divide this by the frequency between quarters. So those two parameters are like written in stone in many new changing models, because those are the parameters John Taylor worked with, and they seem to, they produce these model versus data interest rate paths. And of course, the responses that we are looking at depend on those parameters. So if once we work with the MATLAB file, if we change those parameters, then that's going to change the impulse responses, right? All right, so we discussed those three subplots. Now we need to discuss those three. And what we see is that in response to the better technology, there's going to be more output produced. It's good, right? So in addition to the cut in prices, now customers go and buy more goods. That's right. They buy more tomatoes. Tomatoes get cheaper, and they buy more of that stuff. That's this effect. Now, by how much tomato demand goes up and supply in the economy's key prices is like 0.5. Okay, so 0.5% up. It turns out that potential output goes up by 1%. So there should be also a red line here. For some miracle, it isn't. Right? So there's also these crosses that are exactly on top of the blue line, right? So potential output, why is that? Well, potential output is YTF is equal to 1 plus eta sigma plus eta ZT hat. And it turns out that this coefficient, 1 plus eta, so eta is equal to 1, eta is equal to 1, and sigma is equal to 1. What is this coefficient? That's exactly 1. Thank you, right? So then what you see is that when technology goes up by 1%, potential output goes up by 1%. And that's what we see here in this graph, right? The 1% jump in technology leads to a 1% jump in potential output. Okay, so the little, sad news is that while our actual economy expands by 0.5%, so this is a boom, the efficient response, the potential economy response, is to have output expanding by 1%. So with flexible prices, output would expand by more than it actually does in the economy we live in. So we're not participating in full as a society from the improvements in technology. That's basically what this says. And now, when you do the math and you put together what is again the output gap, now you understand why the output gap actually falls. The output gap xt is yt minus yt hat f. We discussed that so many times. And now you see, this goes up by 0.5%. This goes up by 1%. Well, that must be that the output gap then mechanically is negative, which it is. Then do you want to say that? Yeah, okay. Okay, so that's the idea. Huh? So that's basically how this economy works. So even though we have a positive technology shock that produces a fall in inflation and increase in the level of output, never forget about that. But the output gap turns negative because potential output expands by more than actual output does. Okay. Great. Any questions to this? That's the transmission, so to say, of technology shocks in this model. Do you have any questions on this? So now you're allowed, in the next step, to look at the blue lines. You had to promise me, right, to not look at the blue lines until now. So now let's look at the blue lines. What are the differences? Well, you see, it's qualitatively similar in the sense that with flexible prices, we also get an expansion output, we get a cut in inflation. But now, inflation falls by more. Again, by analogy, right? When prices are sticky, firms are cutting prices by some amount. But when prices are flexible, when we remove the Rothenberg price adjustment costs, you're going to see that firms are cutting prices by more. Always think about this profit function, folks. Right? There's the firm profit function. With omega equal to 0, you're going to remove that adjustment cost from that profit function. And now firms are going to move their prices more freely. And if they move their prices down with adjustment costs, then they will move their prices down by more if you have them not paying that cost. Now inflation moving down by more, guess what happens to the customers? We would be storming the mall, right? Because now prices are down by more, so that will increase output. So that's the key idea. That with inflation going down by more, or prices stepping down, then output will increase by more. If you understand that, then you understand how sticky versus flexible prices work with technology shocks. And then there is a little bit of a miracle here that with flexible prices, I'm kidding of course, with flexible prices, output now goes up by the same amount as potential output. Well, that's by definition, right? I mean, potential output is defined as the level of output with flexible prices. Now we make prices flexible, well then this is again potential output. So output with flexible prices goes up by exactly 1%. And then you shouldn't be surprised that there's no output gap. The output gap is exactly closed. All right. So that's how you can think about the technology shock. And everything I said is written down in words, like the most important elements of it is written down in those 4 bullet points. It's everything we just discussed so far. All right. Are there any questions?
I think it's logic just apply for basic good.
For basic
Basic goods.
Basic goods. Oh, for
Yes,
basic
because,
goods.
For
Yeah.
example, Apple when they release iPhone with new technology, the cost will be higher.
I see what you're saying. Okay. Yeah. So the devil is in the detail when it comes to how do you map the model into some of the intricacies of the real world. I think to fix ideas, one thing is that if you look at the same apple, the quality of the apple doesn't change, right? So you're buying apples, and when when you can produce a cheaper amount of apples or potatoes or rice, it's the same rice, it's the same potatoes, right? And if the firms can produce the same potatoes, the same rice, at so to say cheaper technology or better technology, they're going to cut the price. Then there are sometimes goods like the iPhone, for instance, or cars, that even though there is better production technologies, these goods in the real world seem to increase in price. But the careful thing to do is to realize that the iPhone 17 is something different than the iPhone 5.
Yeah.
Because the quality of the good has changed. Right? The quality of the iPhone, an iPhone 17 can do more than an iPhone 5 can do. An iPhone 17 is a portable photo camera, a financial planner, a calendar, everything at once, and it's better quality than the iPhone 5. And so in other words, you're not comparing again an apple with an apple. Now you're comparing an apple with antibiotics and whatever, a superfood in a sense. So that's the idea to think about that. So ideally, you would need to quality adjust the price of the iPhone. And you get a better quality car, like cars these days are more secure than they were 20 years ago. And you're not going to die as likely when you have an accident in a modern car versus an old car. And again, you need to quality adjust for that. So if you take out the quality adjustment, you will likely see that it's cheaper now to produce the same low quality car that you were producing 20 years ago. Or if you were to reproduce the iPhone 5 today, it would be much cheaper than it was some 20 years ago. So that's a tricky thing of how to think about some of the examples, but my advice would be to follow those type of lines in terms of making sure you're comparing the same good. Does this make sense? Can it help? Okay. So it does apply also to non-basic goods.
How about luxury items?
Luxury items. Well, they're okay. I love this. I like really your curiosity on this. So I think this is where the model is going to fall short. Okay, on the luxury items. It's not because, I think because for luxury items, there's something this model doesn't capture, and that has to do with the household side. There we go. Households in this model want to be cost effective. They have a budget and they want to be cost effective. And so in other words, this is a normal good. If the price of a good goes up, there's less demand for it. And so in terms of micro, it's a normal good. It's not a given good. Okay? So in other words, when you want to think about luxury, at least my understanding of some of the luxury goods is if the price of an Hermes, bag for women goes up, actually people are more attracted to buying that Hermes bag, right? For luxury items, the more expensive they are, the more demand there is. So that's typically a given type good. And so that would require changing consumer preference. I think, actually, I cannot recall a paper who actually did this. I'm sure somebody must have done it. But it would be interesting to look.
A model where like there's a durable and there's the non-durable goods. But then because I think here we model the variety, right? But then I think the underlying assumption is still that there's different variety, but they still belong to the same type of goods.
That's right. But the key idea is like with the preferences that we wrote down, Alexa was your name, right? And Alexa, at the end of the day, we're going to get a demand function for a normal good in the sense if the price of that good increases, the demand for it is going to fall. And my understanding of luxury goods are that if you increase the price of a luxury good item, like a supercar, or like the jewelry or whatever, then people are actually willing to buy more of that stuff. So that's going to require a different type of preferences. And I think it would be very interesting to look into that and to understand, so to say, what happens if you put in luxury items in this model as an additional type of good. I wouldn't advise putting together a luxury good economy because, but say, have two types of goods. Have basic goods in the language of Lin and have luxury goods in the language of Alexa. Have these two types of goods in the economy. And then think about how does the transmission of monetary policy changes once you have luxury goods and basic goods. I would start researching the literature. Go on ChatGPT or your preferred AI or Gemini and research that literature. I think it would be very fascinating to maybe think about Because we have this tendency that, at least in the United States, a larger portion of the economy, in terms of the amount of consumption, is generated by rich people rather than poor people. More than 50% of US consumption is by rich people these days. Okay, so, and we have few rich people. So long story short, I think it's a great question. This is a great question. Yes, all right. Any other questions?
Can I have a quick one?
Oh yeah.
On the slide for the info response here, I just want to leave back is like, the overall intuition is we need the sticky price to model the short run non-neutrality money, right? But then in here I can, so the real effect part here, is it reflecting on the output gap?
Be careful. Always think about which shock you're looking at. This is the technology shock, and this one is the monetary policy shock. Nominal rigidity, the big effect that nominal rigidity has is after a monetary policy shock. If you have no nominal rigidity, flexible prices, no change in output. With sticky prices, you do get an effect on output.
Actually, that was the part that I get confused because in the other diagram, I see that
There we
both
go.
showing the,
Yes.
the increase in the output.
So with technology shocks, flexible prices amplify responses. But there's always going to be a response. That's the idea. So in other words, with flexible prices, what you're going to have is you're going to have more increases in output, rather than smaller increases in output. That's the idea. And maybe go back to, you already studied a model with flexible prices, which is the real business cycle model, right? And you know in the real business cycle model, technology shocks drive the business cycle. Everything in this model is driven by technology shocks. So you have already in your life studied these blue lines. Right? In your life with Professor Haliassos, with Alexander Meyer-Golod, you studied all these blue lines already. This is the RBC model. Maybe annotate this. This is the RBC model. Because this is the response of technology, of output to technology. Okay? You did this already. And now the New Keynesian model is just adding, okay, if you add sticky prices, you're going to see it's going to moderate the increase. Because firms don't cut their prices as much. That's the idea. So, so in other words, maybe say this one more time, flexible prices amplifies the response for technology shocks. Flexible prices takes out the response when you look at monetary policy shocks. That's the key difference here. You guys have more questions? So then let me maybe finish this slide deck. This is the last slide, the main part of the slide deck. Let me maybe just recapitulate what we did here. So what we have learned here is that the presence of sticky prices, that's going to be helpful also for you to follow up on the discussion we just had with Min, right? That monetary policy shocks start to have real effects once prices are sticky. And that they also affect the transmission of technology shocks. So price stickiness affects how policy shocks are technology shocks are transmitted, although it's not leading to a 0-1 case in a sense. Now, and the one thing that many students always have on the forehead says, okay, this is a 3-equation New Keynesian model. It's a very simple model, and I think somebody said this yesterday that these are like a few equation models that try to explain a very complicated reality. If you look out there, the world out there looks more complicated than just 3 equations. I totally see that. I totally admit that. So why are we spending time on studying a 3-equation model? Well, we want to understand what's the driving force in this model that drives the results. And in science, you always try to find what is the smallest model, what's the core that you need to explain the feature of reality. We are not trying to build the world model, because the world model has many other complications in it. We want to understand, what really makes things drive, what's the key element there, and that's price stickiness. Now, once you understand that in a small model, now you can make your model as complicated as you like. And that's what, that's how science does it, and how also policy institutions do it, right? So more elaborate versions of this model, of course, do include physical capital, AI, financial frictions, heterogeneity, and so forth and so forth. And they show that once you enrich the model, the fit of the model to the data gets better. So that's the key idea. You add more, then you don't have 3 equations, you maybe have 50 equations. But I promise you, if we had started yesterday with 50 equations, we would not be here understanding what is the gist of the New Keynesian model. That's basically always the bottom line. And then very frontier research these days focuses on household and firm heterogeneity, so the buzzword is called heterogeneous age in New Keynesian models. So there you make households different. You have poor people and rich people. They have borrowing constraints. You have firms that are financially sound and non-sound, say. They have borrowing constraints. We have departures from rational expectations. So we have a huge literature that thinks about that expectations are formed in a behavioral way or in other forms, departures of the rational expectations. We are moving away from non-linearities. We're moving away from linearizing. And we're going to see this in a macroclimate model. Okay? The macroclimate model we're going to discuss is exactly going to have non-linearities. We're going to have multi-fiscal interactions. Okay? That's going to be a part of our course next week. Among many other aspects, and I should add here, of course, the macro climate is a big topic these days in this field. Great. Any questions? I think technically we should finish in 5 minutes. Practically, can we go until 12:30, or is this a no-go for you guys? Be honest. You're planning for 12:15? Yeah? Okay. Well, then I need to. Okay, good. So what are we going to do next? Then let me use the next 5 minutes at least to get the ball rolling on the next slide deck. And that's going to be at most 20-minute slide deck. It's going to just we need to pass this on before we can understand this one. There's an element in here that we haven't seen in the New Keynesian model yet. And that's what I want to do here. So let me at least motivate what we're going to do in the first 15 minutes of tomorrow. And then after those 15 minutes, I promise, we're going to start with this. Okay? Sounds like a deal? Okay. So let's start off. Let's open this one. The second slide deck of the New Keynesian model. And so that second slide deck of the New Keynesian model is nothing else than just introducing one more element into the New Keynesian model that comes out in many papers. Okay? And that is going to be relevant for the macro climate model and for the monetary fiscal interaction model. And there is a thing in there that's often called a cost push shock or a markup shock. And I need to explain what this literature tries to do. And essentially, it's motivated again by data. This is US data, and it shows the rate of inflation as a time series over time. And the output gap as a time series over time. So those are 2 time series in the data. And this is in a time domain. So this is in time domain. It's a time series. And when you go and work with your favorite econometrics toolbox, like R or Stata or eViews, you can produce plots that are like time domain based, or you can do a scatter plot. Have you done a scatter plot in your life?
Yeah.
Who has done a scatter plot? So that's why, so that's what the bottom line is that. So this is a scatter plot. That is a scatter plot. It plots inflation on the y-axis and output on the x-axis. And each dot is a combination of the data and time domain here. So let's be careful. For instance, this dot here is the largest rate of inflation that we observed in the entire sample. So that must be that dot there. So That is the inflation rate. And then we just look at when did this happen? Oh, this happened at the end of this recession in the 1980s. So this must have been where the output gap was roughly around zero somewhere. And so that's where this comes in. It's about this here. So that's this little point. And so you point every combination of inflation and the output gap in the data, and you're going to get that. And some people say, this looks like a shotgun blast, right? You're hunting ducks or birds or wild animals, and you go with this hunting shotgun that has many bullets coming out of one shot. It looks a little bit like that, okay? Or it's a cloud or a dot plot. So you can compute the correlation, and Drama has it that the correlation of inflation and output is zero. There's no correlation between output and inflation in the data, or the output gap, right? I mean that the output gap and inflation correlation unconditionally is zero. That's a big problem. That's a super big problem. Because we just spent 2 lectures on the New Keynesian model. And you know what the New Keynesian model would say? What this correlation should be like? It should be exactly 1. It should be very strongly 1. And so let me explain why that is. So the Phillips curve that we derived is an object that comes out of this New Keynesian model, and that's a very important paradigm in the field of monetary economics. Right? And that Phillips curve produces a very strong correlation between the output gap and inflation. Let me show you why. Suppose you are assuming that inflation expectations are 0, so that they're not moving. Then you can write the Phillips curve as output is kappa. So that's with 0 inflation expectations, then when the output gap moves, inflation is going to move 1 to 1, right? And kappa, of course, is a positive term. So the Phillips curve says a unit correlation between output and inflation. Okay, so the New Keynesian Phillips curve that we have is like producing something like this, a straight line. But the data says no, it's 0. So there's something wrong with the model. So what we're going to do tomorrow is I'm going to tell you, okay, what does the research frontier, or what the people in this literature do to make the model fit to this shotgun blast. And I'm going to take time tomorrow for 15 minutes. At the end of the day, the way this is going to go is there's going to be one more shock that we're going to put into this model. And there's going to be one shock in the so-called Phillips curve that we're going to consider. So this is exactly the New Keynesian model that we discussed so far. There's the Taylor rule, there's the new IS curve, and there's the Phillips curve, and there's one additional shock in there. There's a shock I named as AT, other papers have this as a UT, and I'm going to explain where does the shock come from, and then I'm going to show you what that shock does. And I'm going to, at the 15 minutes, it's a very brief slide deck. At those 50 minutes, what I'm going to show you is that when you're going to use this model with all the 3 shocks, right? You have the technology shocks, you have monetary policy shocks, and you have these cost push shocks, and you simulate the model with these 3 shocks together, boom, you're going to get a shotgun blast picture that looks like it. And then we're going to, once we have studied this, then we're going to go to the macro climate, and we're going to see that the macro climate paper makes use of a shock like this. Now we're going to think about how climate folds into this shock. That's the plan for tomorrow. So tomorrow, 15 minutes fixing this, and then the rest of tomorrow is entirely macro climate. Plus Wednesday, Thursday, Friday. Okay? Yeah? Thank you so much and have a great afternoon, everyone. Thank you for today.